So in this part of the course, I actually want to take a slight deviation away from diesel engines and give you some background knowledge into maintenance plans and maintenance strategies. The reason I want to do this is because personally I find it enriches your own career if you know a little bit more about the reasoning behind why machines are maintained and why specifically they're maintained in the manner that they're maintained in. For example, 100 years ago, you wouldn't have been changing oil filters or anything like that. In fact, they didn't have anything like that at the time, and this concept of protecting the machinery by filtering out particles or perhaps installing relief valves and things like that, that simply didn't exist. The mentality was not there. And I'm going to explain to you how things have progressed over the past 100 years or so. We can see here we've got types of maintenance programs. We've got what's called a bathtub curve. That's this item here, or this line. And on the x-axis we've got the time, and on the y-axis we've got the failure rate. Now in the past, they used to install a machine, they would put it into operation, and typically you would have a failure rate that followed this line here. That meant that as time progressed, the machine would gradually wear out and one of the components would fail. Sometimes the entire machine would fail catastrophically. And as you can see, as time progresses, this failure rate increases. And this was quite typical for things like boilers. They used to operate them and then they'd just continue operating them until eventually the boiler exploded and then people would die and they'd install a new boiler. So back in the day, that was the way things were done. Obviously nowadays, this is simply not acceptable. Some of the largest companies that exist now for surveying boilers and things like that, they exist because they were born during this period in the 1900s when boilers were literally blowing up all the time. And at some point, somebody turned around and said, look, this is simply not acceptable. Not only are we getting a loss of life, but we're also getting a loss of revenue. Perhaps back then that was even the deciding factor, that they were having plant shutdowns and it cost too much money. Nowadays it's the other way around. A loss of life is far more important than any loss of revenue. So that was the yellow dotted line here, and that's the way things used to be. We also call this maintenance strategy a running to destruction. You literally install a machine and then you'll wait until it dies or stops working. Another common failure pattern was this red dotted line here, the early infant mortality failure, and that meant that the failure rate was very high when you first put the machine into service, but as time progressed the failure rate decreased. So this used to happen quite a lot when manufacturing standards were very vague, or perhaps there was no Q&A, for example, so there's no quality assurance or testing of components. And we'd install the components or the machine and it would simply fail, and then they'd replace the machine and run it again. Maybe that one would fail as well, and eventually they'd put a third one in and this one runs okay and it would continue along its useful working life until here, and at some point it would also fail. However, normally what you get is a combination of both of these red and yellow lines, and you'll have something called the observed failure rate, and that means that as time progresses the failure rate decreases because the machine, it didn't fail at the start, so it's less likely to fail now. Maybe it's already done 1,000 cycles, etc. So it'll continue on its way along the blue line. It'll get to here, and at that point the probability of failure begins to increase because the machine is getting older, components are beginning to wear down, and the failure rate will increase again. And this is our bathtub failure curve, or our bathtub curve. And if you ever look at reliability studies and things like that, failure modes or failure mode analysis and FMECAs or FMCAs, failure mode cause and effects, then you're going to see a lot of curves like this, or perhaps sometimes like this, not so much nowadays, and not so much like this either, unless you're operating with a run to destruction maintenance program. You can see we've got one other green line here, and that is for constant random failures. So there's different ways that machinery can fail. Sometimes it might fail at the start, sometimes it might fail just because it's getting older. But what's really interesting is that as time has progressed, what people have tried to do is get rid of this strong line sloping downwards, get rid of this strong line sloping upwards, and just maintain a line such as this and push that line as far down on the graph as possible. Sometimes what you see is a line that comes up like this, and the reason that it's slightly spiked as it goes along the graph is because as time has progressed, people have performed maintenance, and when they perform the maintenance, the probability of failure decreases again, and we reset it back down to that low failure rate. This isn't always true, and I'll explain why in the next few lessons, but that's the general idea. So that's a bathtub failure curve. Let's just go down and read some of what's going to be in the next few lessons. This course will discuss common maintenance programs currently employed in the engineering world. You will learn about breakdown or reactive maintenance, preventive maintenance, predictive maintenance, and reliability-centered maintenance, or RCM. You'll also learn about the advantages and disadvantages associated with each type of maintenance strategy, and current trends concerning which maintenance strategies are becoming more popular or unpopular. So breakdown maintenance, this is the run it until it breaks or run it to destruction mentality. You'll literally install it and then it will run until it fails. Preventive maintenance, also called scheduled maintenance or periodic maintenance, that's where you will go in and maintain the machine periodically based on the number of service hours or a set period of time, such as 6 months or 12 months, and you'll perform certain maintenance tasks in order that you reduce the probability of failure. So that's preventive maintenance. Predictive maintenance is where we try and predict when failure will occur. Now we can do that by measuring things such as the temperature, pressure, level of vibration, ultrasonic tests, non-destructive testing, etc. We'll get into that in more detail later on. It's a very exciting field that's come through a lot in the past 10 years, and it's now beginning to dominate many plant maintenance strategies. Reliability-centered maintenance is considered the absolute king of all maintenance strategy types. It's a type of maintenance strategy that looks at every machine individually, assesses its criticality, and then matches a maintenance strategy to that specific machine. So in summary, if we've got a motor that is 100% critical to the entire plant, such as a cooling motor or a motor associated with a cooling pump for a nuclear power station, if there was only one, which isn't going to be likely, but if there was, it would be very well maintained because it is absolutely critical to the entire process. The last thing we want is a nuclear meltdown just because the cooling water pump bearing failed or seized. So that's what reliability-centered maintenance is. We're looking at the most important aspects of a process, the most important machines, and then we're maintaining those first, and then we're spending more money on those machines to maintain them than the less critical machines. So that's what we're going to look at in the next few lessons, and we'll see how that relates to the diesel engine as we're moving through the lessons.